we have a quadratic equation right here, and it's already in general form. You see what the general form looks like up here. And we're going to graph it. First thing we're going to do is find the vertex. And you get the vertex by finding negative b over 2a. It gives you the x part of the vertex. And then you plug that into that equation, and then you will find your y part of the vertex. So let's start there. A, B, and C we get from the coefficients. All right, you see here A, B, and C. So A is going to be the first coefficient, which is 1. B is the second coefficient, which is 14. So the vertex is going to be negative b over 2 times a. B is 14. A is 1. Simplify that, and you will get negative 14 over 2, which is negative 7. Okay, so that's the x part of the vertex. To find the y part of the vertex, we need to take that negative 7 and plug it into our function, our f of x. So the f of x equals x squared plus 14x plus 7. The number we are plugging in is negative 7, and we're going to put it everywhere where we saw an x, there and there. All right, let's simplify. Negative 7 squared is a negative times a negative. It's a positive 49 plus 14 times negative 7. Let me get my calculator. 14 times negative 7 is negative 98 plus 7. And calculator again. 49 minus 98 plus 7 is going to give me a negative 42. All right, so at this point I can find my vertex. It's at negative 7, negative 42. All right, I'm not going to count off 7 and 42 tick marks. Let's just assume 1, 2, 3, 4, 5, 6, 7. Let's assume that's negative 7 and negative 10, 20, 30, 40. So negative 7, negative 42, I'm going to put it here in purple, is going to be somewhere about here. Okay, that's our vertex. Next thing we're going to do is determine whether it opens up or down. And this is the same as if it was standard form. Your leading coefficient, if it is greater than 0, it's going to open up. And it's going to be a smiley face because it's positive. And if your leading coefficient is less than 0, it is going to be a frowny face, which opens down. So I look at my leading coefficient. It is a positive 1 that's greater than 0, and therefore it opens up. So from the vertex, I'm going to go ahead and make a parabola that opens up. Let's identify the axis of symmetry. Axis of symmetry cuts this parabola straight down the middle, mirror image. All right, I made some adjustments. Let's assume I'm really good at drawing. And that's a vertical line. So a vertical line always starts with x equals, there's not going to be any y, and h we know is negative 7, right, from the vertex hk. So my axis of symmetry is x equals negative 7. You have to put it like this as an equation. You can't just put negative 7. A vertical line is x equals negative 7. Last thing they want us to identify is the domain and the range. We have no restrictions. So if you don't have any restrictions, you always assume your domain is all real numbers from negative infinity to positive infinity. Okay, and you can see that if you look at the graph, right? Where does this graph stop going to the left? It never stops going to the left. It never stops going to the right. Your domain is all real numbers. But your range does have a place where you're not going to see a range, and that's down here, right? I don't see any graph down here. Where does my graph start? It starts, boom, right here. And that point starts at negative 42. So your range is going to be everything from negative 42 up to positive infinity, right? Because it keeps going up. So range is negative 42 to infinity. Infinity always gets a parenthesis. Does negative 42 get a parenthesis or a bracket? Well, is there an actual graph here at negative 42? Yes, there is. So that point is included in the range, and if it is included, we're going to use a bracket.